Right, next we move on to alkoxide formation, and an alkoxide has a negative charge on an oxygen, so it's a alcohol with a OH with the H removed off the OH, forming a negative charge on the O, and that's called an alkoxide. Now this can be made by using sodium. Now when I say sodium, I'm talking about sodium metal. Now if you look at what sodium metal actually is, sodium metal has an electron on the outside, and this sodium has zero charge. So it's neutral. If it loses this electron, then it becomes Na+. Now, the reason it would lose this electron is because if you look at the electron configuration, sodium has 8 electrons in its second row, and then 1 electron in its third row. And in order to gain its octet, it will like to lose that electron. If it loses the electron, though, this whole thing becomes positive because we've got 11 protons and we have 11 electrons. We take one of those electrons away, it becomes 10 electrons, leaving a net positive charge on the sodium, so we get an Na+ right here. So we're not reacting it with Na+, we're reacting it with metallic sodium, which is a very reactive compound. Now you are aware that sodium reacts with water, and this is actually a similar reaction to the reaction it undergoes with water, because we get hydrogen gas as a byproduct as well. Now you'll notice that the kind of mechanism we're using involves fishhooks. These are single-headed arrows, and we're showing the movement of one electron. So what happens is the oxygen takes the electron off the sodium, and then this bond breaks. We get one electron going onto the O, one electron going onto the H. This second H dot here comes from another one of these reacting with the sodium, and then two H dots react together to form hydrogen gas. So this can be a dangerous reaction, because anytime you get hydrogen gas, you've got the dangers of explosion, so you have to be careful with that. The net effect, though, if we just look at the pattern, is that we take the OH and we can either present this as an ONA like this, or we can present it as O negative Na+. Alright, so these are the two ways of presenting it, ONA or even without the Na on it at all. Now the reason that we can present it in either way is because whenever we're presenting something that's got a positive and a negative charge, like sodium chloride, you can either see it like this, or you can not show the charges and just present it as NaCl, and we can do the same thing over here. But the main point is that the OH has been changed, and we get an O negative with an Na+, which can be presented in any of these particular ways. Remember that the reason we can get away with not showing the Na+ here is because in any reaction that will follow this, the Na+ will end up being a spectator ion and won't be part of the process.